All right, so we're going to talk a little bit about two sample problems for means. So this is independent samples. Holds for either hypothesis testing and confidence intervals. So first we want to look at the conditions for inference, and these are what we've seen before from when we talked about central limit theorem, and same thing as when we talked about one sample inference, right? We need our samples to be random. So it doesn't have to be a simple random sample, but it does need to be random and really also representative, right? You can have a random sample that's not representative, so it needs to be representative. Both of your samples need to be at least sample size of 30 or from a normal population. So very straightforward. These are easy, right? They're the same as they have been. What's a little bit different, and this can cause you some heartache with the web homework, okay, is that the web homework uses what's called the conservative degrees of freedom, okay? This is not what Minitab and GeoGebra and whatever other statistical software will use to find the degrees of freedom for a two-sample problem. It is a really ugly formula. It's quite complicated, pain in the butt to do by hand, and usually results in a fractional degrees of freedom, so like 34.7 or something like that, right? So the web homework is going to ask you to use a conservative degrees of freedom. This means you're going to take your smaller sample size and base your degrees of freedom off of that. So N1, and your first sample size minus 1, or your second sample size minus 1. Okay. Now note on the tests, I am not going to ask you guys to do the two sample calculations. Okay, it's really just for the homework. Okay, so don't stress about it for the test. So we are going to be testing or estimating, so hypothesis test or confidence interval, the difference of our two means when we talk about a two sample test for means. Okay, so we have this, our T statistic, right? Now usually, and it's the same, the usual, here's our data value minus the mean over the standard deviation. So all those parts it's the same t-score that we've been doing, except that everything got more complicated, right? Normally, the mu1 minus mu2 is almost always equal to 0, so that goes away. The square root s1 squared over n1 plus s2 squared over n2, that really is just s over root n, but now we've got twice as many things, right? And we've got our x bar 1 minus x bar 2, that is our point estimate. That's what I just wrote there, point estimate, same as before. And our hypothesis test, the same story, right? X bar 1 minus x bar 2, or the reverse order. That's our point estimate. We've got our test statistic, our T, and we've got our standard error, right? So same as what we've had. So T and point estimate. But we are not going to be hand calculating these things. Okay, so the web work problems require you to use the conservative degrees of freedom. You have two choices here. One is to use what I call the two means tool. All right, with the two means tool, you are going to enter in your sample mean, standard deviation, sample size for your first sample, and then your mean, standard deviation, and sample size for your second sample, along with your confidence level if you're doing a confidence interval, and your conservative degrees of freedom. And this tool here is going to use those lovely formulas from the previous page to calculate the confidence interval lower bound and upper bound. There you go, right there. And the test statistic, the t-score. Okay, so that makes your life easier, right? Now, if you were doing a hypothesis test, you still need to go over to GeoGebra or your calculator or your tables or whatever statistical software you're using to go find your p-value. But this will do your confidence interval boundaries for you. Now, with GeoGebra, you can have it do the hypothesis test, And in that case, it's a two-step process. You were saying, okay, I've got this t-test difference of means. You're going to put in your alternate hypothesis, put in your mean, standard deviation, and sample size for each, and it is going to give you a t-score. Okay? You're going to take that t-score back to students' t-distribution and find your p-value using the conservative DF and the t-score that GeoGebra calculated for you. For the confidence interval, there is a t-estimate difference of means. It is not generally going to give you an answer that WebWork will accept. Okay, you're going to have to use that Excel tool. Okay, so I've got an example, but this is a good place to end here, and then we'll do the ice cream example next.